Hi, here we are in my lab, which is Shelby 2312, and I'm looking at the pdp-8 mini computer, which we've recently managed to get working. We simulated writing small programs on this machine in class using a Java program, but this is the real deal, the real hardware, and I want to make a couple videos here. In the first one, I'm just going to sort of walk you through the hardware and the various pieces of this machine. And then in the next video, we'll do that demo we did of adding two numbers, except we'll do it on the real machine. So there's the front panel with the switches at the bottom for entering numbers and examining the contents of memory. And then there's space for two rows of light bulbs. The machine's turned off right now. I'll turn it on in the next video. Up above the switches, and the selector dial there in the middle right to control what is being displayed on those lamps. So let's zoom over to the top and look at what's in here. There's kind of a motherboard. Not all pdp-8s had a motherboard, but this one did. This bus is called the Omnibus, and you can put various peripherals in the card slots to implement the I/O and memory of the machine. These front boards here, four boards here, are the CPU. There's a board for the controller, for the data path, for timing generation, and I think an interface to the front panel. The power supply is over here on the left-hand side and is connected with these Molex connectors to the underside of the backplane, the motherboard. So each card gets its power off the motherboard, and also all the data and address and control signals needed to execute the processor are there. Here's one of the CPU cards. I have a spare for it, so I took it out. This is actually, let's see, this one, 8310, is the control circuitry, and that's where the problem was that was giving me trouble earlier. One of the bus driver signals was not properly amplifying an onboard signal here that dictated what should be routed to the adders, the ALU, to increment the address. So we were just executing the instruction at address 0, actually at address 1, over and over and over again, because every time, rather than add 1 to the previous address, it was adding 1 to 0. And once we got that fixed and replaced one of these chips, these are not entirely easy to physically unsolder and resolder. You can see each chip has 14 or 16 little wires coming out of it. You've got to unsolder all those without pulling up any of these traces on the circuit board, and that's the real challenge. But then, of course, finding which one needs to be unsoldered, that took me years. We got that fixed, and it's running along nicely now. Behind the CPU boards, there are two boards here. This one is for serial input-output, and you would connect it to a terminal. I just use my laptop as the terminal, but you could use a vintage terminal like this. You're looking at the back of a VT220 terminal on the other side of the bench here. The next module is the thing I'm currently working on, and that's the interface module to a pair of 8-inch disk drives over here. They're sort of all taken apart, but this is the pair of disk drives which are sitting on another, even older pdp-8, a pdp-8L, which remains to be restored. And the ribbon cable here is the interface between the disk drives and the computer. So that's what I'm trying to get working now. That's the only piece in what you see here that's not guaranteed to be functional, though my bet is the card's fine, and the problem is mechanical with the disk drives, which are over 50 years old. The next board is just a shield, an RF shield, to keep the RF interference from the CPU electronics away from the memory. This machine had core memory to begin with. This sort of brighter green card that I'm touching right now is the present memory, and it's a modern board. It's only a few years old. I think I got it in 2018 or so, and it replaces the core memory. The core memory I have, some of it works, some of it doesn't. Let me show you what those boards look like. This is a core memory module. This is a third-party one. Digital Equipment made some. This one's made by a company called Plessy, and it's sort of a two-board sandwich here, if you can see. And the actual cores are not visible. They're inside this board on the back, or they're in between the two boards. The back board just sort of shields the back side of it. Cores are in there, and then this is the control logic to control the addressing and also to do the sensing and amplification of the core memory signals. But this does actually work, but this I'm holding, I think, 4K, and the semiconductor memory card has, so I would need 8 of these to have the full 32K memory of the pdp-8e, while I can, with the one card slot, I can get it all using the modern board. And then lastly, there's a bus terminator card that's just a bunch of resistors. You can sort of see it here, to properly handle the impedances on all the signals on the motherboard. The last thing I'll show is this, which is a kind of a historical curiosity that my modern semiconductor memory board also implements with modern chips. This is the boot ROM, and this holds 32 12-bit words. Each 12-bit word is stored as 12 diodes, and a 0 means there is, means you don't put a diode in a given place, and a 1 means you do put a diode in a given place, and then there's 32 combinations of those. So you could have a 32 instruction long boot sequence on this board, and then there's some more logic to handle addressing and amplifying. And typically these occupied high memory, so something on say the very last page of the pdp-8's memory might have some of its address is taken up by this bootloader, so that you don't have to toggle in the very first program that the machine's going to run with the switches and light bulbs every single time you turn the machine on. And this one, I believe, is the bootloader for the floppy disks. So I have it in semiconductor memory, like I said, or just in normal ROM. On this board, it's this chip up here that implements the bootloader, and that's just easier to fool with. So that's sort of a walk through the hardware. I'm going to, in the next video, toggle in a short program on the front panel and execute it, and I may even make a third video where we run a big program like the basic programming language, or Focal, or maybe a debugger from the terminal. But in the next program, I just want to use the front panel for a short program. So I will see you in the next video.